All right, you guys. So for this reading, you can see the directions written over here in red. You are going to read the assignment. You are responsible for highlighting or underlining throughout the article any main ideas, key vocabulary. You are to annotate 3 times per page. There are a total of 4 pages of reading, so you need a minimum of 12 different annotations where you're actually writing words on the piece of paper about a connection you might have, a question, maybe a summary, or you're defining terms 12 or more times. And then there's also questions throughout the reading in the side margins that you're going to be answering as well. So here we go. Our article is entitled, What is Energy? So starting at the first section. What is energy? A tennis player needs energy to hit a ball with her racket. The ball has energy as it flies through the air. Energy is all around you. But what is energy? In science, energy is the ability to do work. Work is done when a force makes an object move in the direction of the applied force. How do energy and work help you play tennis? The tennis player does work on her racket by applying a force to it. The racket does work on the ball to make it fly into the air. When the racket does work on the ball, energy moves from the racket to the ball. Energy is the reason the racket can do work. So work is the transfer of energy. Both work and energy are written in the same units, joules, or abbreviated with a capital J. After completing this page of reading, you have 2 questions in the margin here. Question number 1 says, when work is done by one object on another, what is transferred? So you're going to go back into your reading. You'll notice this check mark. If there is a check mark, the energy or the answer is going to be around that check mark. Question number 2 says fill in the process chart to show how energy moves when work is done on an object. So they're giving you the first one up here. Work is done by the tennis player on the racket. Move to the next box. So energy moves from the blank to the blank. Then the tennis racket does work on the ball. Move to the next blank. So energy moves from the blank to the blank. Go back in the reading and find the answers to fill in those blanks. Next page. What is kinetic energy? When the tennis player hits the ball with the racket, energy moves from the racket to the ball. The tennis ball has kinetic energy. Kinetic energy is the energy of motion. All moving objects have kinetic energy. Like all other forms of energy, kinetic energy can be used to do work. The kinetic energy of a hammer does work on a nail. This is seen in the figure below. So looking at the picture here, it says the hammer has kinetic energy. When you swing a hammer, it is moving. It has kinetic energy. This energy does work on the nail, driving it into the wood. Calculating kinetic energy. You can calculate kinetic energy or the kinetic energy of an object by using the following equation. It says kinetic energy is equal to the mass of the object multiplied by the velocity of the object squared divided by 2. So here's where it says it again. The M is the object's mass in kilograms. The V is the object's speed. So the kinetic energy of an object is large if the object has a large mass or the object is moving fast. That's how you're going to get more kinetic energy. What is the kinetic energy of a car that has a mass of 1,000 kilograms and is moving at a speed of 20 meters per second? If we were calculating, we would start by writing the equation. Kinetic energy equals mass times velocity squared divided by 2. So step 2, we're putting the numbers into the equation. So kinetic energy equals the mass, which was 1,000 kilograms, times the velocity squared, all divided by 2. Now, it's very important. I want to show you something really quickly here. It's very important that you follow the order of operations. You need to multiply 20 by itself. That's what 20 squared is equal to. 20 times 20 is 400. Then you can multiply it by the mass, which is 1,000, and then divide the whole thing by 2. And so that's where the 200,000 joules comes from. You will need to do that practice for question number 4. Start by writing the equation and then placing your values in. Question number 3 says, for an object to have kinetic energy, what must it be doing? So again, you need to make sure to go back into the reading to find the answers for questions 3 and 4. In addition to 3 or more annotations written in the margins. Next page. What is potential energy? An object does not have to be moving to have energy. Potential energy is the energy an object has because of its position. So this kind of energy is harder to see because we do not see the energy at work. In the figure below, when the bow is pulled back, it has potential energy. Work has been done on it, and that work has been turned into potential energy. So looking at this picture, this guy has a bow and arrow. Okay, this bow has a giant rubber band. It says the bow and the string have energy that is stored as potential energy. When the man lets go of the string, the potential energy does work on the arrow. Next section, gravitational potential energy. When you lift an object, you do work on it. You move it in an opposite direction from the force of gravity. As you lift the object, you transfer energy to the object and give it gravitational potential energy. The amount of gravitational potential energy of an object depends on the object's weight and its distance from the ground. So to calculate gravitational potential energy, it says the gravitational potential energy of an object can be determined by using the following equation. It says gravitational potential energy is equal to weight times height. So the weight is in newtons. And I know that might sound strange because we think of weight in pounds, but when we're talking in science, we've done the calculation and the units are newtons because weight is a force. So again, the weight is in newtons and the height is in meters. Gravitational potential energy is written in newtons times meters. So Newton times meters is the unit, but you could also write it as a joule with the capital J. So again, let's do a calculation. What is the gravitational potential energy of a book with a weight of 13 newtons and a height that is 1.5 meters off the ground? Step 1, write the equation. Gravitational potential energy is equal to weight times height. Step 2, plug in your numbers. So your gravitational potential energy, you're just going to do 13 times 1.5, and that gives us an answer of 19.5 joules. So the book now has 19.5 joules of potential energy. Again, now you have 3 questions. So question number 5, you're going to go back in the paragraph here because I have my check mark. What causes an object to have potential energy? Question number 6, what would the man need to do to give the arrow more potential energy? So a hint for this one, if you want the arrow to have more energy so it would fly farther, what would the man need to do? And then question number 7, you're calculating. It says, what is the potential energy of a 300 Newton rock climber standing 100 meters from the base of a rock wall? Your equation is over here. Step 1, write the equation. Step 2, plug your numbers in. Last page. What is mechanical energy? Look at the figure below. All the energy in the juggler's pins is in the form of mechanical energy. Mechanical energy is the total energy of motion and position of an object. In other words, it is the kinetic energy plus the potential energy of an object. So if you look at this figure here with our juggler, at position A, he's tossing it up into the air. So from A to B, the potential energy increases because it's getting higher away from the ground. As the pin starts falling, it starts falling faster and faster. And so we'd say the kinetic energy increases. Down here it says the mechanical energy in the juggler's pins is equal to the kinetic energy plus its potential energy. Last section, mechanical energy in a juggler's pins. The mechanical energy of an object doesn't change unless energy is transferred to or from another object. Look again at the figure of the juggler. The juggler moves the pin by doing work on it. He gives the pin kinetic energy. When he lets go of the pin's kinetic energy changes into potential energy. As the pin goes up, it slows down. When all of the pin's kinetic energy is turned into potential energy, it stops moving. When the pin starts to fall, its energy is mostly potential energy. As it falls, the potential energy is changed back into kinetic energy. At different times, the pin may have more kinetic energy or more potential energy, but the total mechanical energy at any point is always the same. Again, you have two questions here. It says, adding what to energy gives you the mechanical energy of an object? And question number 9, it says to circle the pin with the most potential energy. So you're going to circle A, B, or C. Do not forget to add your 3 annotations on this page. Once you are finished, you should have 12 total annotations plus questions 1, 2, 3, 4, 5, 6, 7, 8, and 9 all completed. Make sure you go through all of these things to have a complete reading packet.